Welcome back, everyone. We're diving into some fascinating mathematical ideas today.
Yeah, some really old ones.
You could say that. We're talking Zeno's paradoxes. Ever heard of them?
Oh, absolutely. They're classics.
We're using Wikipedia as our main source today.
Sounds good.
And get this, these paradoxes might just make you question if movement is even real.
Haha, yeah, they kind of mess with your head.
So, to start, who was this Zeno guy? And why was he so into these impossible scenarios?
Well, Zeno of Elea was a philosopher way back in ancient Greece.
Okay, so we're going way back.
5th century BC, to be a bit more specific.
Wow, so his ideas have been around for a while.
Yeah, and he's famous for these paradoxes, but they weren't just random brain teasers.
Oh, what was he trying to do with them?
Well, he was actually trying to back up his teacher's philosophy.
Oh, who was his teacher?
A guy named Parmenides. Parmenides believed that reality is, at its core, unchanging.
Unchanging, so no movement at all.
Exactly. He thought what we see as motion is just an illusion, and Zeno created these paradoxes to kind of prove that point.
So he was trying to prove movement doesn't exist. That's a big claim.
Yeah, pretty bold. It's like he was poking holes in reality itself.
I like that, poking holes in reality. So even if his goal was to support his teacher's ideas, did he maybe accidentally spark a bigger debate?
Oh, for sure. His paradoxes have kept people thinking for centuries. They force us to deal with some really deep questions about infinity and how change actually works.
It's like he opened a can of worms that we're still trying to sort through today.
Exactly. I mean, think about it. The idea of motion, it seems so basic.
Right, like we move all the time. It's just how the world works.
But then Zeno comes along and is like, hold on a second. What if it's not how it works? What if it's all an illusion?
So maybe before we get too deep, can we just define what a paradox even is? The word itself sounds mysterious.
Sure. It's basically a statement that seems logical, but then leads to a conclusion that totally contradicts itself.
Huh. So it's like a glitch in the system of how we understand things.
Yeah, exactly. You think you know how things work, and then bam, a paradox comes along and blows your mind.
Okay, I'm ready to have my mind blown. What are some of the most famous paradoxes Zeno came up with?
Well, there's one called the dichotomy paradox. It really gets at the heart of how we think about motion. So imagine you're walking towards a wall.
Okay, picture that. I'm walking toward a wall.
To reach the wall, you first have to cover half the distance, right?
Yeah, makes sense. Half the distance first.
But before you can even cover that first half, you have to cover half of that distance.
So a quarter of the total distance.
Right. And before that, half of that distance, which is an eighth of the total.
I see where this is going. You just keep having it forever.
You got it. And the dichotomy paradox says you could keep dividing that distance in half infinitely.
So an infinite number of tiny steps to reach the wall.
Exactly. And Zeno saw this as proof that motion is impossible.
But clearly we can walk across a room and reach a wall. So what's the catch?
Well, the paradox is really about how we conceptualize motion. We tend to break it down into all these separate steps.
So maybe the way we're thinking about it is what's creating the problem, not the motion itself.
That's the idea. Maybe there's more to motion than just adding up an infinite number of tiny steps.
This is already making me rethink my morning commute. So Zeno is saying that motion is flawed, not impossible.
That's one way to interpret it. He definitely forced people to question what they thought they knew about movement.
Okay, so we've talked about one paradox, the dichotomy paradox. Did he have any others that played with our perceptions of motion?
He did. Want to hear about Achilles and the tortoise?
Oh yeah, I've heard of that one. Something about a race, right?
Right. So picture this. Swift-footed Achilles is racing a tortoise.
Okay, I'm picturing it. Achilles, the legendary hero, against a slow-moving tortoise.
And to be fair, Achilles gives the tortoise a head start.
Hold on. Achilles is known for his speed. Why would he give the tortoise any advantage?
Well, that's where the paradox comes in. Achilles zooms off, closes the distance of the head start.
Okay, so he's catching up.
But in that time, the tortoise has moved a little bit further ahead.
So Achilles is always playing catch-up.
Exactly. No matter how small the distance gets, the tortoise always moves a bit more ahead. It's like this endless game of catch-up.
So even though Achilles is faster, he can never actually overtake the tortoise because he's always stuck catching up to where it was.
You got it. And this paradox really messes with our understanding of space and time.
It seems like it's less about who's faster and more about how we think about distance and time. Like, no matter how small the distance gets, it can always be divided further.
You're exactly right. It's about infinite divisibility. And Zeno used this paradox to argue that motion, as we understand it, is kind of nonsensical.
Wow, these paradoxes, they seem so simple at first, but they really make you question some pretty big assumptions about how the universe works.
That's the beauty of them. They force us to confront the limits of our intuition.
It's like our brains are trying to make sense of two conflicting ideas.
Right. On one hand, we see things move.
But on the other hand, Zeno gives us this logically sound argument for why it might all be an illusion.
Exactly, and that tension is what makes these paradoxes so compelling.
So it's not that Zeno was wrong about motion, but maybe he was just looking at it from a different angle.
I think that's a great way to put it. He was challenging the way we think about movement, and in doing so, he opened up all these new avenues of thought.
So what happened next? How did people respond to these mind-bending ideas? Did they just throw their hands up and say, well, I guess we can't move after all?
Haha, no, not quite. Actually, a lot of brilliant minds throughout history have tackled these paradoxes head-on, and in the next part, we'll explore how they tried to make sense of these seemingly impossible scenarios.
So Zeno throws out these crazy paradoxes, makes everyone question reality. What happens next? Did anyone have a good comeback?
Oh yeah, definitely. A lot of smart people have wrestled with these paradoxes. One of the first was Aristotle.
Aristotle, huh? The big name in philosophy.
Yep, he was a sharp one. And he had some pretty good answers to Zeno.
Okay, like what? How did he try to debunk these paradoxes?
Well, for one thing, Aristotle said Zeno was mixing up two types of infinity, potential infinity and actual infinity.
Two kinds of infinity. I didn't even know there was more than one kind.
Right, but it's an important distinction. So potential infinity, that's something that could go on forever, but doesn't necessarily...
Okay, can you give me an example so I can picture it?
Sure. Think about dividing a line in half. You can keep doing that over and over.
Yeah, half, then half of that, and so on.
Right, you can theoretically keep going forever, but you'll never actually have an infinite number of pieces in front of you.
Right, it's more of a thought experiment than a real thing.
Exactly, like the horizon, you keep walking towards it, but you'll never actually reach the end.
Okay, I get potential infinity. So then what's actual infinity?
Actual infinity is something that is truly boundless, complete and infinite all at once.
I see. So Aristotle was saying Zeno was getting stuck on potential infinity, applying it to things like motion when it didn't really fit.
Yeah, that was part of his argument. He also said Zeno was forgetting something crucial.
Oh, was that?
Time. Sure, you might have an infinite number of steps to cross a room.
Right, that was the dichotomy paradox.
Exactly, but each step takes a shorter and shorter amount of time.
So even though it's an infinite series of steps, they could all happen in a finite amount of time.
Yeah, you got it. It's like one of those math problems, adding an infinite number of fractions, but they end up converging to a real number.
Oh, yeah. I remember those from calculus class.
Exactly. So Aristotle basically said, Zeno's paradoxes, they're interesting, but they don't actually prove that motion can't happen.
So Aristotle kind of brought things back down to earth. He was saying, hold on, let's not get carried away with all this infinity stuff.
Right. He helped people see things from a different perspective.
So was Aristotle the only one who came up with a good response to Zeno?
Oh, no, not at all. Philosophers and mathematicians have been thinking about these paradoxes for centuries.
It seems like they really sparked something in people's minds.
They did, but it wasn't until, well, quite a bit later that we got some really powerful tools to deal with the math of Zeno's paradoxes.
Oh, you mean like when calculus was developed?
Exactly. Calculus really changed the game.
Okay, but calculus can be kind of intimidating. Can you explain how it helped with these ancient puzzles?
Sure. So calculus is all about continuous change. It's perfect for dealing with infinity and things like that.
Right, infinity was a big part of Zeno's paradoxes.
Exactly. So remember how the dichotomy paradox broke down motion into an infinite number of smaller segments?
Yeah, like that endless halving of the distance?
Right. Well, calculus gives us a way to add up all those infinite pieces and actually get a finite answer.
Wait, so you can add up an infinite number of things and get a real number. How does that even work?
It's kind of mind-blowing, I know, but calculus shows that it can work. It gives us the tools to make sense of things that seem impossible.
So we can use calculus to basically solve the math problems that Zeno was posing.
Yeah, pretty much. It helps us see that the paradoxes don't necessarily mean motion is impossible. It's more that our way of thinking about motion needs to be a bit more sophisticated.
So calculus sort of saves the day, at least from a mathematical point of view.
Yeah, you could say that. But here's the thing.
What's that?
Even though we can use calculus to explain the math, some people still think Zeno's paradoxes have a deeper point.
Oh, you mean like a philosophical point?
Exactly. Some people say that even if we can explain how Achilles can overtake the tortoise using math.
Right, we can work out the equations.
Right. But maybe there's still something more to it. Maybe Zeno is getting at something deeper about the nature of reality itself.
That's interesting. So even if the math works out, we can still ponder the deeper meaning of these paradoxes.
Exactly. They're not just about finding the right formula. They're about making us think about the big questions: reality, motion, time.
This is all very thought-provoking. And I'm really curious to see where we go from here. So we've gone from ancient Greece all the way to calculus, trying to untangle these paradoxes. It's amazing how these simple ideas can lead to such complex questions. What's the lasting impact of Zeno's work, beyond the math and philosophy puzzles?
Well, I think one big takeaway is that Zeno's paradoxes show us how tricky our intuition can be.
Oh, how so?
Our senses tell us that things move, right? But these paradoxes, they kind of mess with our heads.
Yeah, they make it seem like motion might not be real, even though we see it all the time.
Exactly. It creates this disconnect between what we observe and what logic seems to tell us.
So Zeno is basically challenging us to think harder about things we take for granted.
Yeah, like we assume motion is simple, but these paradoxes show that maybe it's not so straightforward after all.
So we have to be careful about just trusting our gut feeling about things.
Right. It's a good reminder to always question what we think we know, to be open to new ideas.
It's like he's saying, don't be so sure of yourself, keep learning.
Haha, yeah, something like that. And that's important not just for math and philosophy, but for anything, really.
Always be curious, always be questioning. Now, earlier we mentioned something called the quantum Zeno effect.
Oh, right.
It sounded like it connects these old paradoxes to modern physics. Can you tell me more about that?
Sure, so the quantum Zeno effect is a real thing observed in quantum systems.
Okay, so this is actually happening in the real world.
Yep, and it gets its name from Zeno's arrow paradox. Remember that one? Where the arrow seems frozen in time?
Yeah, because at any given moment, it's not moving.
Right, well, in quantum mechanics, observing a system can actually change how it behaves.
Wait, so just by watching something, we can affect it?
It's kind of wild, right? The quantum Zeno effect suggests that if you constantly observe a system, it can actually prevent it from changing.
Hold on. So by looking at something, it might stop it from changing. It's like our observation is freezing it in place.
It's a bizarre concept, but that's essentially what the quantum Zeno effect proposes.
It's like something out of science fiction. I mean, who would have thought that Zeno's ideas about motion would end up being relevant to the world of tiny particles?
It's pretty amazing, right? It shows how connected different fields of study can be.
It's like these ancient paradoxes have echoed through time, influencing how we understand the universe even today.
Exactly. They've gone from philosophy debates to modern physics.
And they still make us think about the big questions.
Absolutely. They challenge us to examine our assumptions and to keep searching for deeper understanding.
This has been an incredible journey. I feel like I've gained a whole new appreciation for Zeno's paradoxes.
Me too. They're a real testament to the power of human thought. Even after all these centuries, they still have the power to surprise and inspire us.
Well, thank you for joining us on this deep dive into Zeno's paradoxes. We hope you've enjoyed exploring these mind-bending ideas with us, and we encourage you to keep questioning, keep exploring, and keep those minds sharp.